Hello guys and welcome back to CS with Mr. G. In this lesson we are looking at our last topic within Unit 3 where we will be looking at network hardware and hardware in particular that exist in devices that connect to the internet. So although it might seem like a technical topic being called network hardware, but any device that connects to the internet will all contain the parts that we're about to look at in this lesson. As you can see, there are 4 syllabus topics we need to cover. The first one being the understanding of an NIC. And NIC stands for Network Interface Card, and we need to know what one of those is. Next up, we have the differences between a MAC and an IP address. So we need to know the purpose of a MAC address, the purpose of an IP address, and the differences between them. And then finally, we have the role of a router in a network. So a term that you might be familiar with, but we have to explain on a technical level what this device actually does. So as I mentioned, this is the last topic within Unit 3. It's quite a large unit, but well done if you've made it this far. And I hope you've managed to follow along up until now. So the first device I've mentioned is an NIC, which is a network interface card. And an NIC is the part of a computer, a phone or a laptop that allows this device to connect to the internet. And when I say the internet, I just mean network in general, but typically it would involve connecting to the internet in most scenarios. The NIC is the part of the device that the media access control is given to. And this term media access control is what we call a MAC address. And if it's something you're not familiar with, we will go over the basics in this lesson. There are 3 forms of NIC that you might have seen. And if you own a desktop computer, or at least built one yourself, you might have seen it in any of these 3 forms here, where you might have even installed it yourself. As you can see, this one on the left is a wired NIC, and this would exist in a desktop computer that would only be able to connect to a network via a wire, and typically an Ethernet connection that would go in there. The next one is a wireless NIC, and as you can see, it's got a small antenna here, and that would allow the computer to connect to a Wi-Fi or wireless connection. But as you can see, both of these devices have these green circuit boards on the side of them, and this green part would slot into the motherboard on a desktop computer and allow that computer to connect to a network. And like I said, if you've built a computer yourself, there's a good chance you might have seen these if your computer connects to the internet. Or if you haven't, you might have just bought a USB version such as this, which again allows you to connect to a network, or even offers your computer a Bluetooth connection so you can use wireless devices such as a mouse, keyboard, or games controller. So as I mentioned, if you've got a desktop computer, these 3 forms you would have seen. However, in 99% of all other devices, phones, laptops, tablets, an NIC is typically built into the device onto the motherboard where you'd have no requirement to install it. And it's not something that you'd ever be required to change or upgrade. It's built into the device and it lives there for the device's lifetime. As it says there, they are an absolute necessity if your device connects to Wi-Fi. And as mentioned, it provides your device with a MAC address, which gives it an address so it can receive data when connected to a network. So when it comes to a MAC address, we need to think back to our Unit 1 lessons about binary and hexadecimal, as a MAC address is made up of 48 bits that are displayed as 6 groups of hexadecimal digits. So you've got 1, 2, 3, 4, 5, and 6 sets of pairs which are written in hexadecimal, and this is a device's MAC address. So this terminology, guys, is very important. You need to know how many bits are included in a MAC address and how it's displayed in terms of 6 groups of hexadecimal digits. So these 2 terms are very important, especially when we need to compare it to an IP address, which again will follow up in this lesson. We then need to split the MAC address up into 2. And as you can see on the left-hand side, this is what we call the manufacturer's code. And this will be a unique identifier for the manufacturer of that device. So for example, all Apple devices will have the same manufacturer code, all Samsung devices would have the same manufacturer code, and so on and so forth. So the part on the left, the first set of 3 pairs refer to the manufacturer of the device. And then the part on the right is unique to each device. So if you own 2 MacBooks, especially if they were built from the same series, the part on the left will typically be the same as they are both Apple products, and then the part on the right would be different as they are unique identifiers for each device. You can see an example MAC address here. The first part in green again refers to the manufacturer, and the second half refers to the device. But if you notice, it's written in hexadecimal. If we need to think back to hex, remember you can use the numbers 0 to 9 and the letters A through F. So any one of these digits can be 0, 1, 2, 3 to 9, or the letters A through to F. Hence why you've got zeros here and the Fs here. Now, believe it or not, 48-bit addresses allow for a possible 281 trillion devices. So there probably won't be a need to extend this number in our lifetimes, as 281 trillion different devices will be hard to match, as there aren't 281 trillion devices on the Earth right now. But as you can imagine, moving forward, this number could well be met. And once it does, what we'll need to do is make this number bigger to allow for more MAC addresses. And remember, this address is given to the NIC. You can't typically change an NIC in most modern devices unless, like I said, you have a desktop computer where you could swap it. So if you've got a laptop, a tablet, or even a phone, it will be very difficult to change the NIC, meaning that the MAC address would live with that device for its lifetime. Now, when it comes to an IP address, this is also an address that is used to identify a device, but it's not physical, and this is something that will change as your device connects to different networks or different Wi-Fi hotspots. An IP address is not physically assigned to a device. Now, what happens is when you connect to a network, typically a router or a Wi-Fi hotspot, that router or Wi-Fi hotspot behind the scenes is being given access to the internet by an internet service provider, or what we call an ISP. So at home, whichever company you pay to access the internet for your Wi-Fi, this is your ISP, your internet service provider, and your router uses this company in order to access the internet. Now, each router is given a unique IP address by this company so that it can be located in order to transfer data across the internet. This address will definitely be unique, and no other device on the internet will have the same IP address. Otherwise, there could be a mix-up when data is being transferred to each address. Just like your house address, this is a unique address to your house. You have a street name, you have a house number, you have a postcode. So all these things add up to make up a unique address for your house so that you can receive post and that people know how to find you and you wouldn't get mixed up with two different addresses. So an IP address serves the exact same purpose, but like I said, it's specifically for accessing the internet. And if you didn't know, IP actually stands for Internet Protocol, something that is discussed in a later unit. Now, we do have to show a knowledge of IP and in particular the different versions of it, starting with IP version 4. And IP version 4 are made up from 4 bytes or 32 bits. So remember, MAC addresses use 48, whereas IP version 4 uses 32 bits. So it's a bit smaller. Not only that, IP version 4 didn't use hex, it uses denary, and it's separated by full stops, not colons like the MAC address. So the number is a bit smaller, and it also doesn't use hexadecimal, which means that the amount of unique addresses that can be used in IP version 4 is a lot less than the amount of MAC addresses that can be used, which was over 280 trillion. IP version 4 actually allowed 4.3 billion addresses, and as you can imagine, with the amount of people that have devices in houses or in companies, we actually reached the limit of devices using IP version 4 in 2019, hence why we needed to move over to IP version 6 to allow for more unique IP addresses. So although 4.3 billion sounds like a large number, if you imagine every household has typically 5 or 6 devices nowadays, it's not actually that difficult to reach this number, hence why we needed IP version 6. And what IP version 6 did to make sure we didn't reach that limit again was extend the number to 128 bits, which as you can see allows for a very, very large number. And as I've mentioned there, it's very unlikely that in our lifetimes we'll see this number reached, but once we do, again, we'll just move on to the next version of IP, but we don't have to worry about that just yet. Now, what's important for IP version 6 is that it uses the technique used in MAC addresses in that it uses hexadecimal rather than denary, and it also separates each group of digits with a colon and not a full stop. So all these points I'm making, guys, are very important to the syllabus. I have seen past paper questions asking you to differentiate IP and MAC addresses or spotting errors within each addresses, and all these differences between the amount of bits and colons and full stops is important, but hopefully this is clearing it up for you, and I will go through a summary of differences in a second. But as I've said, IP version 6, 8 groups, 4 hexadecimal digits in each group, and they're separated by a colon. There are also some other techniques used when writing IP version 6 addresses, and as you can see, hexadecimal digits, in particular the letters, should be written in lowercase. So the B, the D, and the C in this address should be written like this here, in lowercase. Also, any leading zeros in a group of digits do not need to be written, so this group here, 00B3, can be shortened to just B3. And if it's all zeros like this one here, we can just put 1 0 to represent the 4. And finally, if we have repeating groups of zeros, we can shorten this and replace all of the groups with just 2 colons. So as you can see, we've got 1, 2, 3, 4, 5 groups of just 0. So we've used the technique from here to shorten it to just 1 0, But then we can also simply write 2 colons to represent these 5 groups to make the address much shorter. And the computer would know how many groups are missing from the amount of groups either side of the double colon. But these techniques, guys, again, you might have to spot these errors in an exam question. And when I post a Unit 3 review video, I will include some of these questions so we can give it a go and have some practice. So a quick summary of the differences of IP version 4 and 6. The size literally quadrupled. It went from 32-bit to 128-bit. The amount of addresses went up exponentially from 4.3 billion to 340 trillion. And again, a very, very, very large number. We also changed from full stops to colons, very important. And just to note, it's not just more addresses that IP version 6 offers, it's also improved security using techniques that we will go over in Unit 5. Next up, we have routers, and we do have to show a bit of knowledge on a technical level, more than just the Wi-Fi box in your house. So although it is the device that you connect to in your homes, typically where your Wi-Fi password is located, we do have to show some knowledge of what's actually going on, especially when it comes to the terms IP addresses and what's actually happening when we send data across a network. So in the first bullet point, a router is the device that sends data to a specific destination. And if you've managed to work it out, this will be using the IP addresses for each device. So the router at your home or school or place of work will what we call route packets from your device across the internet to a server or to another computer, which is what a network does. Connects devices together and allows them to communicate. And it's a router that allows us to do this. So a very easy to understand example is your home Wi-Fi network. And whatever devices you have at home, whether it's a laptop, desktop, or even a phone, they connect wirelessly to your router, which behind the scenes connects to the internet and allows you to transfer data and receive data back. So if you're streaming a film on Netflix, the data's coming in through the network into your wireless router, and the router will know which device to send it to. And again, in order to do that, it will use the IP addresses and MAC addresses of your devices in order to make sure it's going to the correct device. Now, what happens every time you connect a device to a network or to your home network, the router uses something that we call a DHCP server, which stands for Dynamic Host Configuration Protocol. Don't worry too much about this technical term, but the DHCP server is what assigns each device a unique IP address. So the DHCP server will know which addresses have been used and will assign a new unique address to each device. So for example, in this diagram, if this was the first computer connected to the network, it's given this IP address, which ends with 100. The next computer comes along, this one connects to the network, and the DHCP server gives it the address 101. The third one comes along and gives it 102. So as you can see, each address will be unique. This first part, we don't need to worry about. That just simply refers to your home network or to whichever network you are connected to. But the end part, the last part, refers to each device. And again, this will be unique and it's assigned by the DHCP server. So this could be you, your mum, your dad, brother, sister on your home network, and you will be given a unique address by this DHCP server. And the last technical term we need to describe for a router is what we call a static and dynamic IP address. So as I've mentioned, a router is what assigns your device with an IP address, and each router is given an IP address from your ISP, like we've said. And what happens is that sometimes your internet service provider will give different IP addresses each time the router connects, or it could stay the same. So static and dynamic is a term you'll hear frequently throughout computer science. Static stays the same and dynamic will change. But when it comes to IP addresses, if your IP address needs to stay the same, for example, a website or a web server, it's very important that the ISP keeps this address the same so that if people are trying to access your website or your web server, they can access it because the IP address hasn't changed. Let's imagine you have 2 homes and you live at 2 different addresses and you're ordering a product online. Now, if we compare this to a dynamic IP address, in that your address can change between the 2 different addresses, this product that you've ordered online is getting delivered. Now, the delivery might go to this address, but you could be at the other address at the time of delivery. You're not in to collect the delivery, and it's sent back or put in a safe place or whatever the delivery company does. Now, if this is very important and you need this delivery, you would need to let the delivery company know that it's a static address and that it wouldn't be allowed to change so that it's delivered successfully and that it's at the right address. So what's important is that dynamic can change, static can't. And if you can remember that, you should be fine when it comes to these different types of IP addresses. So in summary, a router gives you a wireless access point for Wi-Fi. It connects your local network, your home network, and office network to the internet using what we call a modem. So a modem is a device built into the router, and the router's job is also to assign IP addresses to each device that connects to it. So that's it, guys. That concludes Unit 3. This is one of the more trickier lessons within Unit 3, and we will discuss IP and MAC addresses more in a later unit in Unit 5, but don't worry about that just yet. Coming soon will be a Unit 3 review video, where we will look at past paper questions specifically from Unit 3, making sure we cover what's expected from the mark schemes when it comes to device hardware. So as always, guys, I hope you've managed to follow along and understand the points I've made. Thank you for watching, and I hope to see you in Unit 4.